solve the system of equations in two ways. I want you to know how to do it algebraically, and then in class today we learned how to use the new app, the intersection map, in order to find where the two lines cross, essentially finding out what would be the value of x and the value of the y that makes these two statements mathematically true. So let's start by doing this algebraically. I'm going to take this value that y equals, and I'm going to substitute it in wherever I say y. So 3x plus 4, I'm not going to write y, I'm going to write what y equals, 5x minus 7. And now I'm going to distribute the 4. 3x plus 4 times 5 is 20, 4 times negative 7 is negative 28, and I'm going to continue to combine like terms. 3x and 20x is 23x. So as I'm trying to isolate the x, I ask myself, which one should I move first, the 23 or the negative 28? There is a right answer. You want to move the value that's not touching the x. In fact, we're going to do PEMDAS backwards. Please excuse my dear Aunt Sally. So we're starting by moving by adding or subtracting. So opposite of subtraction is addition. So I'm going to take and move 28 to the opposite side. 8 plus 8 is 16. And I end up with 46 on the right-hand side. Now on the left-hand side, I'm left with 23. Opposite of multiplying is dividing, and I have an answer of 2. Now, too often students do all this beautiful work and they stop and they think, I'm done. When we look back up to the original system of equations, I see two unknowns, either x and a y. Well, I figured out the x, now I have to solve the y. It does not matter which equation you choose to use. I'm going to use the first. And instead of putting an x, I'm going to substitute what x equals. 5 times 2 is 10, and 10 minus 7 is 3. That means when I graph these, I should see these two linear lines crossing at the ordered pair 2, 3. This is algebraically one way that you could solve the system of equations. Now, could we solve this using technology? We sure could. How can we do that? So I'm going to start by plugging in the first. Now you do have to have it in the form mx plus b. So mx plus b. This is not in that form, so I got to do a little work. I'm going to take this equation, write it down, and remember I want to put it into y equals mx plus b form. So how do we do that? Ultimately, I just need to get y by itself. I need to isolate the y. And so I need to first start by moving the 3 to the opposite side. Right now it's a positive 3x. I'm going to subtract it to the other side. These are opposite and cancel out. Now I need to move the 4 to the opposite side. Opposite of multiplying is dividing. Okay, finally y is by itself. How can I properly write this? This 4 must be shared with both the left and the right. So negative 3x over 4 and positive 18 over 4. And yes, you could reduce 18 over 4 to 9 over 2 or leave it like this. So let's go on now and put this next one in. First parenthesis is negative 3/4 x plus parenthesis 18 divided by 4. I'm going to graph these. And I'm looking to see where do they intersect. Where they intersect will identify the specific x and y that makes this mathematical statement true. Well, how do I find that? Well, to find the precise point, we're going to use the app on the calculator. Second, trace, and we're going to go down to intersect. And then I'm just able to hit enter, which is in the bottom corner 3 times. Enter for the first curve, enter for the second curve, and enter for guess. This is the exact points where they meet, and that's exactly what we came up with when we did this algebraically.